And welcome to Module 5, ACLs for IPv4. So in this module we'll actually be concentrating on the actual configuration of standard and extended ACLs and how to apply them to the device, either on the interface or on the VTY lines. We'll also go through the ways of editing existing ACLs, and we'll start off with our standard ACLs. So you learnt in Module 4 what ACLs are, the access control lists, and in here we'll be recommending that you use a text editor such as Notepad to actually create your ACLs in. Now this will allow you to write out your security policies in a functional manner in the Notepad, so you've got a clear understanding of what you need to do to implement that policy in the ACL. We'll be going through the line-by-line configuration parameters. We'll be showing you that you can make comments, which are called remarks in ACL, so that when you come back later on, you will see what the ACL is doing. We'll highlight the fact that you can copy and paste from Notepad into the device, saving you a lot of typing, especially when you're learning and making a few mistakes. So it's very quick and easy to make modifications and update the ACLs on the device. And how to test your policies with your ACLs to make sure they're working as expected. So the command structure for a standard ACL is in global config, access list, the access list number, and then the parameters. So the first three options are your actions: permit or deny, or remark. So when you want to add comments, you use the remark parameter and then the text for the comment. Following that, if you're doing a permit or deny statement, you put the source and the source wildcard. So as we're doing standard ACLs, basically doing 1 to 99, and then the extended range is 1300 to 1999. The other optional keyword here is log, which generates a message, informational message, to a syslog server if you wish, whenever that particular line is matched. As per usual with all the other command line, to remove the access list, you do a no in front of the access list command, and then identify which access list you wish to remove, and that'll remove all of the access list. You don't have to remove it line by line, you just delete the entire thing at once. Named ACLs are slightly different in command structure, in that in global config we go IP access list, we tell it it's going to be a standard, and then we specify the name of the ACL. This now changes the command prompt into named ACL configuration, and we go through and add our parameters. Now we only have to do this from our permit deny action onwards. We don't have to keep typing in IP access list 10 permit like we would with a numbered one. So it can save quite a bit of typing. Same options are basically there, just the procedure for creating it is a little different. We then go to the interface we wish to apply the access list to, and the command is IP access group, and then the identifier for whether it's a named or a number, and then the direction of the traffic that we wish to filter. So remember, when we're doing the direction, it's for the direction of the traffic entering or exiting the interface. Okay, so is it coming into the router or leaving the router on that interface? So inbound and outbound. So here's a couple of examples. So we have access lane 10 and a remark saying what we're going to be doing. So we only want to permit the host to travel to the internet. So it's a permit host and the address, and then we want to continue and go, we're going to also permit all hosts on the LAN number 2. So the actual command is access list 10 permit, and then that second network with the wildcard mask representing the network, which is a /24. So if you do the show access list now, you can see both of those lines in sequence, one after the other, and then you go to the interface and apply it. IP access group 10 out, so it's an outbound on the serial interface. Now, only a word of caution here, you don't need to do the show access list command like they've shown it here. Normally you would just put all your commands one after the other, exit and then apply. Okay, if you forget and actually not do the do command in front of the show access list and you exit the config, you will not be able to get a working access list if you do the second step after you've exited and amended it. There's an explicit deny all statement at the end of each ACL that is not visible. So if you accidentally just do a show access list after the first line and you exit the config and then come back in to do the second set of commands, there's a deny statement between line 10 and line 20, so nothing from line 20 onwards would be actioned ever. So just be aware of that little item. So you can check your configuration with the show running config command, or you can view the application of the access list using the show IP interface and specifying the interface that you want to look at, and within the output we'll have the outgoing and inbound access lists listed, and you can see whether it's been applied to the interface or not. So if we want to change our numbered to a named, we have to first remove the access list 10, then create our named standard ACL, again going through the same remarks and permit statements, and then apply it to the interface. So exactly the same procedures, just slightly different format for the difference between a numbered and a named ACL, but we apply it the same way with IP access group, the access list identifier, and the direction. So command show access list will show us every access list that is configured on the device and all the associated command lines with that access list, whether it be a remark or not, it's visible. Okay, so you can go through and check it. The only way to see whether it's applied to an interface is with the show IP interface command. Alright. Yes, if you look at the interface in the running config, you'll have the command line there, but it's best to get used to using your show commands rather than the config command. The reason being is when you're going through the testing and even the certification exam test, you will need to prove you understand all the command structures. Okay, if it asks you to show something and you just show the running config, that's not actually answering the question, because the question wasn't show me the running config where this is. It was, for example, show me all the access lists on this device. So the correct command for that would be show access lists. Just be aware of that one. Now, modifying your ACLs once they're on the device, you can edit them within the device, but word of warning, you can get very unexpected results by doing that, because we can inject information in using sequence numbers, because as you create the ACL, each time you hit the return at the end of each command line, it generates a sequence number to match that line that you've just entered, and it automatically increments them so that they're kept in order as they're put in. So you can go in and make edits and changes using the sequence number to insert information if you wish, although this is not the recommended practice. So the best practice is to copy it out to a text editor, make your changes, then when you're ready to reapply, you go in, delete the old access list, and then copy and paste your new one in. This one avoids the issue with the implicit deny statement that is not visible to you where it's applied. Alright, so use the text editor method, copy it out, make the changes, paste it back in after deleting the old one. So again, here you could go in and remove the statements with the sequence number and then reapply them. Just be aware that you cannot edit past the last statement. Okay, so sitting directly under sequence 20 is the implicit deny anything. So if you delete line 20, say line 20 in this example had the typo of 19.168.10.0, you would move that implicit deny statement to under line 10 when you delete line 20. So the way if you wish to do it this way by modifying the sequence number, and it was line 20 that you wanted to change, you would have to insert a sequence 19 with the new line 20 and then delete line 20. It's the only way you can get around it. So you can add sequence numbers in, remove them, in both named and standard ACLs. It's safer to do it in a named ACL than in a numbered, but you still have that issue of that invisible deny any statement that is at the end of any access list. When you look at how your access list is performing and traffic has been filtered, you will see a match statement against the line. That's how many times that line has been matched against traffic flowing through the interface in the direction that that access list is applied. These are a counter and can be reset at any time that you wish. So clear access list counters can clear the counters for all counters on the device, or you can specify just to clear the counters against a specific access list, depending on what you're trying to do. Okay, so when we are trying to secure our device for remote access using a access list to filter the traffic, we have a slight different way of applying it to the VTY lines. The command is now access class, not access group. Okay, works exactly the same as the access group command. Why they've changed it to access class, no idea, but it works exactly the same way. So we create the ACL, then apply it to the line using the access class command, then identify the access list that we're using and the direction that we're applying it in. So in this example, we've set up a username with admin and a password of class. We are then creating a standard access list that is named admin host, and we're permitting that host only and denying any other traffic. We then go to the VTY lines, tell it to log in using the local username database. We're saying that the only transport input allowed is via telnet, and access class admin host in, so only connections coming from the host 192.168.10.10 will be permitted to open a VTY line. You then, after that, go through the normal login credential verification. Okay, so any other host can't even attempt to log into the device. Only traffic from that specified address will be able to attempt to log in using the local credentials. So if we have a look at what's going on router 1, we will see that a login was successful, and then you would see the matches for each line. So because you've got to deny any statement at line 20 with 2 matches, it means somebody else has attempted to connect and has not met the criteria. Extended ACLs. Now this is where it gets a little bit more interesting, because we can now filter on source address, destination address, and protocols being used and port numbers. So it becomes more finite. So we have absolute control over this filtering. So if you look under the protocols, which we need to specify after the action command. Okay, so if we were doing a standard address, this is where we would put in the IP source. Okay, but because we're extended, it's now asking for the protocol that we're wishing to take action against. That being IP, TCP, UDP, DNS, whatever protocol there is. Remember, we have 256 protocols listed against protocol numbers that are well defined. So we can use the protocol number if we know it, or if it's part of the named protocols listed there, we can use the name. So we're all used to referring to IP, TCP and UDP all straight away. ICMP we're used to using the echo command for our ping, for example. Now when we get to specify the port or the applications that we wish to filter against, again we can use the dedicated port number or any of the named options there. So for example, if we wanted to filter port 80, we could use www instead, or we could just type in 80. Okay, so if you look here, there's our options. So it tells you what the port numbers are that correspond to that name. So you can go through and list them off. So how does this work? Well, access list 100 being it's an extended numbered, the action permit, followed by the port number, the source any, destination any, equal to www or port 80. Now when going through these examples, you see that it's only using the destination port numbers there. Just be conscious that we can filter on both the source and destination as far as port numbers are concerned. So again, we apply it in exactly the same manner as we did our standard ACLs. We go to the interface and we type in IP access group, the number of the ACL and the direction we wish to apply the filtering. Now, one of the new options available to us is using the established keyword. Now, as you cast your mind back to TCP, we have a three-way handshake. We send a request for a conversation and the destination replies with their synchronization to start their conversation and acknowledge our opening request. So this is an established conversation. In other words, we've got an acknowledgement coming back, whereas if you're opening a session from the internet, you wouldn't have any acknowledgement within the control field because it hasn't established that communications yet. So we can add this onto the end of our access list parameters and apply it as per normal, and when the traffic is coming back, if it does meet the rest of the criteria, but it's missing the acknowledgement control bits in the field, it will not match. Okay, so it must meet all the criteria as well as having an acknowledgement flag bit set in the header for it to completely match the criteria and be allowed. As with standard, we can create named extended ACLs using the exact formula. Instead of standard, we say extended and follow that by the name of the ACL. This will again change you into the editing mode, and instead of STD, it will have EXT next to the name ACL in the parameters. So in this example, we want surfing to permit web traffic, both secure and unsecure, to exit across to the interface for the internet. And when browsing returning traffic will be allowed if it's established. Okay, so again, using our established keyword on the reply. So as we exit, we create the extended surfing ACL, which permits any inside traffic to go to any outside web page, be it secure or insecure, so port 80 and 443, from our network. So our internal network is 192.168.10.0 to any internet address equal to port 80 and 443. Then the second access list is standard browsing, and we're permitting TCP traffic from any source. Now we don't want to specify the conversation parameters because it may shift the port number as part of its negotiation for the conversation, but we know it will be coming back to our network address, so 192.168.10.0 with the wildcard mask on and established. We then go to the interface that we wish to apply it on. Surfing is going in, browsing is going out. So we then do a couple of searches on the internet and then check our access list command with the show access lists, and we'll see what is being matched against surfing and browsing, and we can see how many packets have been permitted. So with this one, sort of again, it's talking about the counters, and in the previous page, I mean, they should have used the same graphic as the last page here, going back, because it shows the matches, but that's what they're talking about. We can see using the show access list command that each time we ping or connect to a web page, we would get more matches and the counters would increase. Again, you can clear the counters just like we went through last time. There's no difference between standard and extended ACLs as far as counters are concerned. So sequence number 10 in surfing is got the incorrect access list source. It's got that typo of 19 instead of 192, so you won't be getting any matches because the source doesn't match. So normal WW traffic is being dropped because it doesn't match. It's not coming from the 19 network. So again, you can go in and remove the line and then replace it. Again, I would recommend copying the ACL out to a notepad, making the changes and putting it back in. Again, the no IP access list extended surfing would remove the entire access list and then posting it back in with the modifications in place is my recommended approach. Okay, so basically the same scenario here, but we're doing it on many different protocols for the same host. So here we're allowing this host out to the internet using ports 20, 21, 22, 23, 53, 80 and 443 and denying all other traffic out. Then any traffic that is TCP coming back, that is established going to this PC. And again, we apply it with the access group command on the interface, one going in, one going out, and we would have matches against those protocols. To verify that these access lists are applied on the interface, you use the show IP interface command, and we're looking for that outgoing and inbound access list to have the named ACLs listed in the correct position. Using the show access list, you would see all the access lists that are configured on the device and what their parameters are. It won't tell you where they're applied, it will just tell you that they exist. You can also look at the running config to see any remarks or comments that have been made within those ACLs. So in summary, we looked at the actual command structures for numbered standard ACLs and how to apply them to an interface. We looked at using the notepad to make our statements so that if we make a mistake and have to make any edits, we can make the changes in the notepad, then remove the offending access list with the no access list command, and then reapply the correctly modified ACL. We then went through the named standard ACL and its various parameters being basically the same as the numbered version. The difference between IP access group and IP access class being groups are applied to interfaces, class is applied to lines. So remember that one. Now, the extended ACL has a lot more parameters for you to configure, but it follows the same formula for every line. The access list, then the access list number, so there's an IP in front of that, remember. Your action, Then you have your source wildcard mask, and source port numbers. Then destination wildcards, and then your destination port numbers. Then you've got the established and log options after that. We also went through the fact of the requirements for established. It basically only works with TCP traffic because that's the one that uses those control bits. Okay. Remember, we don't have that three-way handshake with UDP. It's only in TCP that we have that reliable traffic. We also stress the best practice is to use a text editor to update and edit. You can use the sequence numbers within the device to make changes in the command line, but we don't recommend that procedure. You may get unexpected results by doing it that way. That concludes the configuration options here, and I highly recommend that you now spend the time going through the labs with this module, because by actually doing the labs and getting practice and experimenting with your traffic to see what matches and what doesn't match your ACL parameters, and seeing what happens if you go through and edit on the device and add something after the last sequence number that was there originally, that it will never get a match in the traffic, because not shown is that implicit deny statement, and that will get all the traffic matching it before your edited third line, for example. So have a play, explore. It will embed a greater understanding of ACLs, and I can guarantee you that there will be some or options around ACLs in your skills exam at the end of the course. So make sure you get a good understanding of how they're used and applied in the device. Okay, so that brings us to the end of this module. Thank you for joining me, and have a nice day.